First off, I'd like to start by thanking you for taking the time to attend today. My name is Lance Zurich, and I'm the product manager for the Fischertechnik division over here at Studica. And today I'm going to provide you with an overview of Fischertechnik's line of pre-assembled industrial simulation and training models. Now, whether you're an educator at the high school level, let's say involved in something like CTE training, if you're maybe a college professor or an industrial trainer, teaching programming skills required in manufacturing, maybe you're with a company looking for ways to demonstrate your software-based solutions, or you're just looking for someone looking for ways to make IoT-related concepts easier to understand to employees or customers. In any of these instances, I believe this presentation is going to offer some important options for you to consider. And we're going to start off by considering the skills gap. Now, if you've attended any of our other Fischertechnik education webinars, you've probably heard me talk about the importance of STEM education. And of course, STEM's an acronym which stands for science, technology, engineering, mathematics, and it really goes without saying that STEM education has been perhaps the most discussed topic in education over the last decade. Now, as most of us are aware, the push for developing STEM skills in students is in large part to help to best prepare them to take their place in the modern workforce. Not so long ago, when our parents or our grandparents were entering the workforce, employers in areas such as manufacturing might have been satisfied with hiring workers who could demonstrate good motor skills and a solid work ethic. But as manufacturing becomes more and more dependent upon automated processes and robotic control, employers now desperately need individuals who have a background in areas such as mechatronics, industrial electricity, mechanical components, and programming PLCs. And as it ties in directly with the solutions we're going to be looking at in this presentation, I'm going to stop and consider that last skill area that I just touched upon, that of being a PLC programmer. First off, in case you're not familiar, a PLC is an acronym. PLC, the term itself, is an acronym, and the letters of which stand for Programmable Logic Controller. And essentially, a programmable logic controller, or a PLC, is a very specialized computer that's used to control the types of machines and automated processes that are typically found in an industrial setting. And these are, of course, going to be things like an automated manufacturing plant, for example. Now, as the world of manufacturing becomes increasingly dependent upon these automated control systems, of course, the need for workers skilled in the programming of systems like this grows exponentially. And to give you a clear idea of just how highly prized these skills are, here are some salary figures for PLC programmers that were quoted on the job search website nuvu.com. Quote, the average PLC programmer salary in the United States is $78,000 per year, or $40 per hour. Entry-level positions start at $43,924 per year, while most experienced workers will make up to $132,600 per year. Now, as I prepared this webinar, I took a look at the list of what were then current job openings for PLC programmers on the Nuvu website, and this was back in the beginning of February 2020. And the listing at that time showed 15 open positions being advertised with salaries of over $75,000, and two of which even listed salaries well above the experienced workers quote I just mentioned. They listed salaries of $195,000 per year. Now, because of this trend, savvy students are increasingly enrolling in PLC programming classes at the college and university level. And at the same time as this potential workforce of tomorrow is getting their training, more and more manufacturing companies that are facing the urgent need right now are enrolling their workers into private training programs offering these types of programs. So how long does it take to learn PLC programming skills? Well, depending on a student's background and experience, very basic PLC programming skills can be learned in as little as 30 to 40 hours of training. But of course, to become truly proficient, for example, in all 5 of the major PLC programming languages that I have listed on the screen right now, as well as learning how to efficiently troubleshoot and address errors and equipment breakdowns, of course, with that, more training would be required. Now, once again, while many students can learn PLC programming skills in a college lab setting, there are other options that are available. There are high school CTE, career and technical education programs, adult continuing ed programs, vocational training, technical training, and trade schools, And as I mentioned before, the employer-sponsored incumbent worker training programs. Now, the dilemma for educators is, of course, whether you're in the university or the vocational school setting, is how do you teach PLC programming in a way that makes it engaging and relevant to the student, whatever their background? How do you get away from the dryness of textbooks and video presentations and instead make it more realistic and make it hands-on? But before we go there are other areas of focus beyond programming that need solutions for demonstrating, exploring, and understanding different aspects of automation and control systems. Now, it could be, for example, a company involved in creating or marketing a new type of software based solution that's looking for ways to make more tangible processes which might otherwise be perceived as abstract or to test it out in a more realistic fashion. Could be a manufacturer looking for ways to better visualize the production process for workers or stakeholders as they prepare to build a new factory. Or perhaps it could even be a company looking for an engaging way to demonstrate their services or solutions in a public setting, something like, let's say, a trade show. Now, in any of these cases, and there are probably more, there's a need for finding a solution that is engaging and which can effectively mimic and simulate real world automated systems. And that brings us to the line of Fischertechnik industrial simulation and training models. Now, these models have been designed with the intent of providing a compact, engaging, and hands on method for teaching and demonstrating high end automated systems. The line consists of a series of pre assembled small scale models which are designed to replicate in both appearance and function various automated robotic machines and systems that are commonly found in commercial manufacturing. So, before we get deeper into the models, let me provide you with a little bit of background on what Fischertechnik is all about. Fischertechnik has been creating tools for teaching students of all ages how technology works for well over 50 years now, based around their unique building system. Now, what makes their building system unique is that unlike other popular construction systems where the components are designed to simply stack, with the Fischertechnik system, it was created with more of an engineering mindset. The core building block in the system is designed to enable attachment from all six sides, and because of this, it allows for almost limitless design possibilities. Many of the parts are designed to slide together and lock in place using a tongue and groove assembly method. And the hundreds of different parts available will also help to address very specific design needs. The system was created back in the 1960s by German inventor Arthur Fischer, who's noted for countless innovations used in both the construction and the automotive industries. Now, Mr. Fischer, at the time of his death back in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fischertechnik, Mr. Fischer was the inventor of synchronized flash photography, and that was back in 1949. And he's also credited as the creator of the expanding nylon wall plug, which is commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, employs thousands of workers worldwide, producing many variations of fastening devices that are used in building construction. And they also produce numerous components that are used in the automobile assembly process, as well as providing consulting services to companies who wish to employ state of the art manufacturing processes. Now, once again, the focus of Fischertechnik sets, and it's whether those intended for the retail market or those that are designed specifically for classroom use. In either case, the focus has always been on helping to foster an understanding of technology and how things work. Now, many of the products offered by Fischertechnik for the education sector are what we call subject specific sets, focusing on different STEM related areas such as mechanics, pneumatics, robotics, renewable energy, and other such topics. And in each of these sets, students are asked to build a progression of models using the unique Fischertechnik building system, and then they perform various experiments which allow them to explore and understand aspects of that subject. And there are also additional sets that can include a certain amount of curriculum that can be built around a project-based model where students are going to go through a trial and error process of building things and answering different questions, and all the while learning about technology. Now, the line of Fischertechnik simulation solutions, which are, of course, the focus of today's presentation, are something much different. Again, the line consists not of kits, but again of a series of pre-assembled small-scale models which are designed to replicate in appearance and function various automated robotic machines and systems. Models that you'll find in the Fischertechnik simulation line include things like conveyor belts, punching machines, 3-axis pick-and-place robotic arms, color sorting lines, and even high bay warehouse storage systems. Now, besides these individual models, which of course focus on specific automated processes, Fischertechnik also offers an integrated factory simulation model. In this case, the model consists of 4 individual workstations, a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection that are designed to all work together as one self-contained material cycle. Now, before we begin to look at the models in the simulation line in detail, let me very briefly outline some of the advantages of using Fischertechnik solutions. Now, I have to apologize in advance as a few of the points are things I've already touched upon, but in each case, I do think it's worth repeating. First, Fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this could be for understanding how automated systems work, or for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models are also, again, designed to realistically replicate in both appearance and function common automated systems, things such as conveyor belts, sorting machines, robotic arms, and more. Now, besides the fact that because the models are compact, in most cases, these are tabletop sized models, they are not only ideal for use in the classroom or for in office demonstrations, but also for demonstrating software or other technology based offerings in a trade show environment. The next factor is quality. Each Fischertechnik simulation model is a hand assembled, high quality German made product. Each of these models is available in a 24-volt version designed specifically for use with industry standard PLCs. Now, it doesn't matter whether you prefer, let's say, Allen Bradley controllers, if you prefer Siemens controllers, or if you use controllers from from manufacturers, such as Honeywell, Mitsubishi, General Electric. You could, of course, name many others. You can control the 24-volt versions of the simulation models with the PLC you prefer. Likewise, just as you can use your choice of controller, you can also use your preferred programming language of the types listed on the screen now. Please note, though, that with these 24-volt versions, no PLC is included with the model itself, with one exception, which we'll touch on later. And all programming and programming guidance, as well as any power sources or other hardware, are the responsibility of the end user. Of course, this shouldn't be an issue as these models are designed specifically for industrial users or for those who are involved in teaching or exploring industrial processes involving PLC programming. But for those who are non-industrial users or for educators who aren't versed in or familiar or focusing on PLC programming, there are several models which are available in 9-volt variations. In the case of these 9-volt variations, they ship pre-wired to Fischertechnik's own proprietary robotic controller, which is the Robotics TXT controller. In this case, it's the newly upgraded TXT 4.0. And each of these controllers is pre-programmed using Fischertechnik's own RoboPro graphic programming software. Now, when we're talking about the 9-volt versions, the only additional component that will be required will be the addition of one or more 9-volt power adapters as specified with each model. Otherwise, in most cases, these 9-volt versions should be ready to use out of the box. Now, if you're involved in demonstrating or exploring IoT, also known as the Internet of Things, besides the fact that many end users have adapted some of the models in the primary line of simulation and training solutions for IoT purposes, Fischertechnik now also offers a special IoT-focused version of the factory simulation model, which is designed specifically for exploring and understanding cloud control and what is often referred to as Factory 4.0. Now, in the case of this model, it's designed to be both controlled and monitored from a special web-based dashboard. And we are, of course, going to look at this in more detail a little bit later in the presentation. Finishing up our advantages, finally, the Fischertechnik simulation models are cost-effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation options that are available in the marketplace, you'll probably notice pretty quickly that the entry point for many of these products can easily be $20,000 to $30,000 or even much more. Fischertechnik simulation solutions, on the other hand, are available at just a fraction of that price, as well as, again, being compact, realistic, and high-quality learning and demonstration tools. So on that note, we're going to jump right into our review of the models. And we're going to start off with the vacuum gripper robot. Now, what you're going to see in this video is the vacuum gripper being a 3-axis robotic model with a vacuum gripping device. The model you're going to see is designed to precisely pick up and position workpieces in 3-dimensional space. The model itself includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, which is the blue brick component that you see in the video, and a solenoid valve. The dimensions of the model are approximately 9 by 19 by 15 inches, and it has a weight of only about 7 pounds. The 24-volt version of this model, as well as all of the first 5 24-volt models we're going to be looking at today, each have a relay board for motor polarity reversal and both a multi-pin connector with 34 pins and a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, this 24-volt model, as with all of the 24-volt versions we're going to look at, will require you, the end user, to provide the PLC and the programming, the wiring from the PLC to the model, and so on. I will also mention that for this and for all of the models we're going to look at today, the specs are also detailed in the product listings found on the Studica website, as well as in our product brochure, which I will provide information on obtaining at the end of this presentation. I'm just going to let this play out for another second or two. And there we go. Next model we're looking at is the automated high bay warehouse. The model you're going to see here features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays, along with 9 individual storage spots. Components on the model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, and a selection of different colored workpieces along with carrier trays for each piece. I will mention that this particular model is a favorite among educators that I've spoken with who teach programming. And the reason for that is because it gives you a lot to work with in regards to the movements of the picker mechanism, as well as the precision required to properly store and retrieve each of these work pieces, each step of which, of course, requires very specific coding. So because of that, they like the detail that's involved. Getting to the dimensions for this model are approximately 19 by 28.5 by 15 inches, and it has a total weight of about 18 pounds. Again, the 24-volt version has a relay board for motor polarity reversal and both the multi-pin connector with 34 pins and a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Again, you do need to provide your own PLC and programming. And there is a limited edition 9-volt version also available at this time. Again, pre-wired to the pre-programmed TXT controller, and 1 9-volt power adapter is required for that. The next model we're looking at is the multi-processing station with the oven. And what we're going to see here is a model featuring a furnace simulation with a pneumatic sliding door. There's a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components used on this model include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions on the model are approximately 20 by 14 by 12 inches, and it has a weight of just about 11 pounds. And again, the standard version of this model is the 24-volt version for use with the PLC of your choice, with once again a relay board for motor polarity reversal and both a multi-pin connector, again 34 pins with a grid of 2.54 millimeter, as well as additional PCB terminals with pushing connections for all inputs and outputs. And the limited edition 9-volt version in this case is connected to 2 robotics TXT controllers. So in that case, 2 9-volt power adapters will be required for all operations. And there we go. So next up in our presentation is the sorting line with color detection. Okay, where'd we go? We're going to silence that. Now, the simulation model you're going to see here features a system for detecting workpieces of different colors, and it sorts them via conveyor belt into 3 different storage bins. Components on this model include 2 mini motors, 5 push button, or excuse me, 5 photo transistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions on the model are approximately 20 by 14 by 12 inches, and it has a weight of just about 10 pounds. Now, as with the models we've looked at before, the standard 24-volt version again has the relay board for motor polarity reversal. And again, the multi-pin connector, 34 pins, grid of 2.54 millimeters, as well as the additional PCB terminals with push-in connections for all inputs and outputs. And again, you do need to provide the PLC in the program. And there is a limited edition 9-volt version, which comes pre-wired to the pre-programmed robotics TXT controller, and in that case, 1 power adapter is required. We'll just let this sort through the pieces. The next model we're looking at is the factory simulation, which combines the 4 models that we've just reviewed. Again, the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with the oven, and the sorting line with color detection, combining them all into one self-contained material cycle. The cycle you're going to see works like this. Work pieces are retrieved from the automated high bay warehouse using the vacuum gripper robot, and then they're moved to the multi-processing station with the oven. And after the workpiece has been processed by the multi-processing station, it's then sorted by color in the sorting line with color detection before being again moved by the vacuum gripper robot back to the automated high bay warehouse for storage. Now, as we've already discussed the components of each model previously, I'm not going to belabor that by restating that here, but what I do want to impress upon you are the dimensions of the model as a whole. Now, as it combines these 4 individual models into one cycle, it does have a much larger footprint, as you see. In this case, it's approximately 39 by 31 by 16 inches, and the weight is between 43 and 46 pounds, depending upon whether we're talking about the 24-volt version or the limited edition 9-volt version. Now, due to these dimensions, please note that this factory simulation and any of the factory simulations we're going to be looking at today, we'll be looking at several later, that these do need to all be shipped flat as freight, and they will ship on a pallet. So this is going to be truck shipping. I also want to point out that as the factory simulation models do tend to be in higher demand, especially during the summer, please anticipate a possible turnaround time of possibly up to 2 to 3 weeks prior to any order for this model leaving our warehouse. Now, a few things to note. First off, this is currently available in the standard 24-volt version and in very limited quantities in the 9-volt version. Now, in the instance of the 9-volt version, it is wired to 5 robotics TXT controllers, and because it's got 5 controllers that happen to be daisy chained, you will need 3 power adapters with this. Again, as always, the 24-volt version will require the end user to provide the PLCs, the programming, and any other hardware that's required. Now, before we move on to the next group of models, I do want to mention that there is a storage option available for those users of either of the 2 factory simulations we've just discussed who will need to transport the model or who want to protect it when in use. Now, in this case, the travel case consists of an aluminum case maker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model, and it also has 3 internal zipper pockets for storing cables and other accessories. The lower portion of the case is lined with hard foam, and it's designed so that once the top of the travel case is removed, the model can remain in the bottom section of the case and be fully functional. The case has exterior dimensions of approximately 41 by 33 and 7 by 17 inches, and it has a weight of about 53 pounds. And I do have to impress that please note that when using the travel case, these models still need to be shipped flat. So even though we have the travel cases sitting on their side, you would want to ship this flat or store it flat. And I will mention that this can be used also for the Trading Factory Industry 4.0 models that we're going to examine a little bit later in the presentation. But moving right along for now, we're going to look at the conveyor belt. And it's a basic conveyor belt with a length of 275 millimeters that is used to transport work pieces with a diameter of up to 29 millimeters. You could connect multiple conveyors to increase the length of transport as desired. That can be easily done with a few extra Fischertechnik pieces. Components on this model include an excess motor, a push-button limit switch, 2 phototransistors, and 2 LED light barriers. Dimensions are approximately 14 by 10 by 4 inches, and it has a weight of about 2 pounds. As we stated before, the standard 24-volt variation includes a multi-pin connector, but in this case, it's a little bit different. It's 26 pins with a 2.54 millimeter grid as seen here. And for a limited time, we still do offer 9-volt versions of this pre-wired to the robotics TXT controller as shown here. And in this case, one 9-volt power adapter is required for operation. The next model is a variation of the conveyor belt that makes it into a punching machine. And this basically is the same conveyor we looked at, except this time you have a machining station built on. Components on this model include 2 excess motors, 2 push-button limit switches, 2 phototransistors, and 2 LED light barriers. The dimensions are 15 by 12 by 7.5 inches with a weight of about 3.5 pounds. Again, it's available in the standard 24-volt variation, again with the 26-pin connector and the 2.54 millimeter grid, as shown in this picture. And we do have a 9-volt version wired to the robotics TXT controller, which again requires 1 power adapter. The next model is the indexed line with 2 machining stations. And this model features a U-shaped conveyor line consisting of a milling and a drilling station and 4 conveyor belt sections. Components on this model include the 4 conveyor belts I just mentioned, 8 excess motors, 4 push-button limit switches, 5 phototransistors, and 5 LED light barriers. The dimensions of the model are approximately 19 by 18 by 11 inches, and it has a weight of just about 8 pounds. Again, it's available in both the standard 24-volt version with the 26-pin connector and a 2.54 millimeter grid for use with your PLCs, and it does have a 9-volt version wired to the pre-programmed robotics TXT controller, and this will require one 120-volt power adapter, or 9-volt power adapter, I should say. The next variation is on the idea of a pick-and-place robot, the 3D or 3-axis robot. Now, the 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the work pieces it picks up in 3-dimensional space. The degrees of freedom for this robotic arm are as follows. Axis 1 turns 180 degrees. Axis 2 can move forward or backward, 90 millimeters, and axis 3 can raise or lower 150 millimeters. Components on this model include 2 excess motors, 2 encoder motors, and 4 push-button limit switches. The dimensions are approximately 19 by 16 by 9 inches, and it has a weight of just about 6 pounds. And again, this comes in either a 24-volt version with the 26-pin connector and 2.54 millimeter grid designed for use with the PLC programming of your choice, or in a 9-volt version, which in this case is not a limited availability model. This is a regular Fischertechnik model. It's a standard model, and it does come pre-wired to the robotics TXT controller and requires 1 power adapter with that. Now that's the first 9 variations of simulation models, the main industrial simulation line. The next grouping of simulation models that we're going to be looking at focus specifically on the area of IoT, and they're designed for demonstrating and teaching about cloud-based monitoring and control. And these models go under the umbrella name of Trading Factory Industry 4.0, and they are available in both 24-volt version for use with PLC, and there's also a 9-volt variation for classroom and demonstration purposes. Now, these models have been designed to help address how the recent changes in industrial production, driven by digitization, have created a need for stronger networking and more relevant information on all production levels. Now, with this Industry 4.0 update of the factory simulation model that we looked at earlier, Such digitization activities can be simulated, learned, and applied on a smaller scale before, of course, they're implemented on a larger scale. Now, as the following video showcasing the 24-volt version provides a nicely narrated overview of all the features and exactly how the factory works, I'm going to step back for a moment and allow you to watch and listen to the narrator. So just to summarize some of the points that were touched upon, with the Training Factory Industry 4.0, you can do training and simulation on a realistic production model. You have in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance. You have the linking of production materials planning data, and connection of upstream and downstream logistics processes. Now, as you just saw, the model incorporates many features not found in the models that we looked at earlier, besides most notably being the use of the cloud-based dashboard for monitoring and controlling the model. Now, some other examples of things that are unique to these models would be the camera that's used for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each individual workpiece, each of which has a unique identification number, enables the positions of each workpiece in the work cycle to be mapped. And the use of MQTT, or message queuing telemetry transport, allows the network TXT controllers to communicate with one another. Now, as there are two variations of this model, let's go over what makes them different, aside, of course, from the voltage requirements. And we're going to begin by focusing on the 24-volt version and what makes it unique. Now, first off, it is a bit of a hybrid in that while requiring a PLC for operation and control, it does also incorporate one Fischertechnik robotics TXT controller. And in this case, the TXT controller serves as the MQTT broker and interface to the Fischertechnik cloud. Communications between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. Now, OPC UA, also known as OPC Unified Architecture, is a standard for exchanging data across different platforms. In addition to the TXT controller that's used here, there is also an IoT gateway using Raspberry Pi with Node-RED. And this allows the option for not only presenting and using data on a dashboard in the Fischertechnik cloud, but also being able to display data and calibrate the stations of the factory in a Node-RED dashboard. The model also incorporates newly developed 24-volt adapter boards to interface to the PLC. These, of course, ship as part of the assembled training factory, are connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allows the speed of the encoder motors to be controlled via PWM, or pulse width modulation. And they also have push-pull output stages for phototransistors and for buttons. And finally, one of the most important new features. Now, unlike any of the other 24-volt models that we looked at earlier today, the new 24-volt Training Factory Industry 4.0 models also include access to a sample program. In this case, the program itself is in structured text format, and it was created around a Siemens S7 1500 PLC. And this program is available for download on GitHub. Now, of course, the new Training Factory can also be controlled with other PLC models besides the Siemens and brands once the end user makes some small adjustments to the sample program. And for anyone who wants to do that, the source codes needed are also available for download on GitHub. Now, as with the first of the 24-volt models we looked at today, the Training Factory Industry 4.0 has the relay board for motor polarity reversal and both the multi-pin connector, again, 34 pins with a grid of 2.54 millimeters, along with PCB terminals for pushing connections for all inputs and outputs. And again, all this information and much more is included in the materials that you can download right from the Fischertechnik or the Studica website, including the 152-page PDF manual that accompanies this. And of course, if you need access to that, you can also connect with me at the end of this presentation. You'll have information on doing that. Now, in the case of the 9-volt version, the control is facilitated through the use of 6 robotics TXT controllers. Now, unlike all the other 9-volt versions we've looked at previously today, these are programmed not using RoboPro, but in this case, using C, C++. Again, all of the programming is preloaded so that once connections to the internet and the cloud-based dashboard are made, all of which is clearly outlined in the downloadable documentation PDF that accompanies this model, once you've done that, you should be able to get started pretty quickly. The 9-volt version will require the addition of 3 120-volt power adapters. Of course, it goes without saying that both of these models will also require that you have the ability to access the internet, as well as a tablet or device for accessing cloud-based dashboard. Now, just finishing up with the dimensions of the models, you're looking at approximately 39 by 31 by 16 inches and a weight of approximately 51 to 53 pounds, depending on the configuration of TXT controllers or not. Now, as with the other two factory simulation models that we discussed earlier, we recommend the optional travel case to help protect the model during travel or storage. And that's the Training Factory Industry 4.0 model, now available on both 9-volt and 24-volt versions. So, how much do these models cost? So, at this point, we're going to do a quick review. I've discussed a lot with all the models I've discussed, along with the pricing for each of the options. First up, the vacuum gripper robot. This is only available in the 24-volt version for use with PLC. Requires the PLC, of course. And you're looking at $1,129.95 list price for that. The automated high bay warehouse in the 24-volt version is $1,369.95. In the 9-volt version with the TXT controller is $1,318.95. That is limited. The multi-processing station with oven in the 24-volt version is $1,199.95. The 9-volt version is $1,479.95. That comes with the TXT, of course. The sorting line with color detection in the 9-volt version is $1,049.95. In the 9-volt version is $1,128.95. The factory simulation, this is the standard factory simulation, the non-IoT version. The 24-volt version is $4,829.95. And the 9-volt version with all the TXT controllers is $5,239. The conveyor belt in the 24-volt version is $324.95. In the 9-volt version, it is $518.95, and that, of course, comes with the TXT. The punching machine with conveyor belt, 24-volt version is $419.95, and the 9-volt version is $599.95. The 3D robot, 3-axis robot, these are both standard versions that are available consistently. The 24-volt version is $999.95 list price. The 9-volt version is $1,369.95. The index line with 2 machining stations in the 24-volt version is $1,129.95. And the 9-volt version is $1,394.95. And the Training Factory Industry 4.0 for exploring and understanding IoT-related activities. In the 24-volt version, you are looking at a cost of $8,999.95. And in the 9-volt version, you're looking at a cost of $9,024.95. But there are 2 other versions that are also available. The new Training Factory Industry 4.0 24-volt version with a PLC connector. So what this version would include is it includes the PLC connector board and the wiring, which normally requires a lot of extra work on the end user's part. So the wiring from the model to the PLC connector board is also included with the PLC connector board. The cost for that model is $12,079.95. And then there is another version that comes and it includes everything, including the Siemens PLC, the S7 1500, and of course, all of these Training Factory models have access to that sample program and structured text format that comes with this. But in any case, the educational version of the model with the PLC is $18,499.95. And the commercial version of that is $20,124.95. 2 other items to mention here. The power adapters, 9-volt power adapters are $12.99 each. The travel and storage case, which is used for all the factory simulation and training factory industry 4.0 models, is $1,524.95 each. And there is breaking news. There is a brand new model called Quality Control with AI. And the quality control with AI system model from Fischertechnik is ideal for visualizing this complex subject matter in a hands-on fashion, as it creates a sustainable learning experience by linking theory and practice. Processes can be sped up, fault rates and costs minimized, and fault evaluation standardized. And the Fischertechnik sorting line here comes with workpieces in 3 different colors. And these workpieces are marked with 3 processing characteristics, as well as 3 different fault patterns. Now, in this case, the workpieces are scanned by the camera and classified with the aid of trained AI. Now, depending on the color, the feature, and the fault pattern, the workpieces are then sorted by the artificial intelligence on the basis of their quality features. The AI used is realized with machine learning in TensorFlow, where an artificial neuronal network was trained with image data. The learned AI is executed on the Fischertechnik TXT 4.0 controller, and the model sequence control is implemented in the RoboPro coding programming environment and in Python. Now, if you want to go a step further, you do have the option of generating your own AI applications as well, and the training for this is done in Python, for which a suitable example project is provided as well for explanation and for examination. Now, these are just coming in now. We're waiting the first shipment of these later this week. Here's some more photos. As you see, that's the new 4.0 controller on there. And right now, it is only available in a 9-volt version. You're looking at a cost of $2,089.95 each for those. The 24-volt version is not yet available, but we are looking at a potential release date of fall 2023. So that was just kind of added in there. That is just become available. Now, at this point, if you do have any questions, I would ask you to use either the chat window that you can find on the Zoom toolbar, or you could use the question and answer window that's also there. Either of those will work. If there is anything that you'd like to know. Otherwise, as there is only one person on the call with us, I'm going to move right over here to taking the next step. So if you would like to request a full color brochure on current pricing, if you'd like to ask any questions about anything that I've discussed directly or find out more, if you'd like to request a quote, if you would like to speak with your dedicated educational representative, any of these things, you can simply call us at Studica. The number toll free is 888-561-7521. If you have more general questions about this, you can simply email us at info@studica.com. If you have questions, specifically about anything I discussed today, anything that you wish I would have touched upon, or anything Fischertechnik related, you can email me directly. Same thing, as I mentioned several times during the presentation, there's documentation, what have you, that's available if you would like to see any of that. Just mention what you're looking for. You can email me directly. My email, as you see down there, is lance.zurek. That's lance.zurek@studica.com. So on that note, I'd like to thank you very much for taking the time to attend today's presentation. We do look forward to hearing from you, and I hope you have a great day. Take care.